Welcome back to the AI Architect Lab. Today we are exploring a paradigm shift in generative AI, synergizing reasoning and acting through the powerful ReAct framework. Today, we dive into one of the most transformative concepts in modern generative AI, the ReAct framework. ReAct stands for reasoning and acting. Introduced in groundbreaking research by Yao et al., it addresses a critical limitation in traditional language models. While models are fantastic at generating human-like text, their ability to reason through complex tasks and dynamically interact with the outside world was traditionally weak. ReAct changes this by synergizing reasoning and acting. It allows the model to generate reasoning traces and then, based on those traces, perform relevant actions. Serious. Recent advancements in LLM agent frameworks leverage this plan and act paradigm. It explicitly separates high-level planning from low-level execution to improve performance on complex, multi-step tasks. Unlike single-model approaches that just guess an answer, ReAct intermixes reasoning and action in one pass, allowing the application to access internal data stores, APIs, or perform web searches iteratively. It transforms an LLM from a static encyclopedia into an active, autonomous agent capable of solving multi-step real-world problems. This flowchart captures the cyclical nature of ReAct. A user prompt triggers a reasoning trace, which leads to an action execution. The system observes the results. If the task isn't complete, it loops back to reasoning, creating an autonomous problem-solving engine. To implement ReAct, we must structure our prompts to guide the model through a very specific sequence. This is the question, thought, action, observation loop. Let us define these four critical components. The question represents the user-requested task or problem to be solved. Next is the thought. This is the reasoning step that demonstrates how to approach the problem and identifies a potential action. The model thinks out loud. Then comes the action. This is where the model invokes a predefined API call or function from a set of allowed operations. Finally, the observation. This is the result or output obtained from executing the chosen action in the real world. For example, question: what is the optimal inventory level? Thought: I must balance levels based on demand forecasts. Action: invoke optimize inventory levels API. Observation: maintaining at 80% reduces stockouts by 30%. Amazed! This structured approach forces the model to break down complex tasks into actionable, verifiable steps. Look at the anatomy of the prompt sequence. The model receives the question, generates a thought to formulate a plan, executes the action using a search tool, processes the returned observation, and generates a final thought before delivering the answer.
An LLM isolated from your enterprise data is of limited use. The true power of ReAct is realized when we define tools for the model to use. How does the model know what it can do? The set of allowed actions is defined by instructions prepended to the system prompt text. We must provide strict, clear descriptions of each tool so the model understands exactly when and how to use it. For example, we might equip the model with a SQL query tool. The prompt from the human might be, provide an updated financial summary report for any company. The model's thought process will trigger, the user is asking for financial information. To answer this, I need to query the database, so I will need to use the SQL query tool. The model then outputs an action input, such as select asterisk from financial DB where company equals any company. The system executes this against your actual AWS backend and returns the tabular data as an observation back to the LLM. Amazed, the LLM then synthesizes that raw data into a beautiful natural language financial summary. It bridges the gap between conversational AI and backend infrastructure. This illustrates tool integration. The LLM's thought process decides to query a DB, triggering an action and action input.
This executes against the enterprise database, returning tabular data as an observation, which the LLM then synthesizes into a human-readable answer.
Manually parsing thoughts, actions, and observations in Python loops is tedious. Fortunately, orchestration frameworks like LangChain abstract this entire complexity away. An agent in LangChain is a high-level abstraction that combines an LLM, a set of tools, and an execution engine to coordinate the ReAct loop automatically. Let us look at how this is structured programmatically. We initialize our Amazon Bedrock LLM, for instance, Anthropic Claude. Then we define our tools. LangChain provides built-in tools like Wikipedia API Wrapper or YouTube Search Tool. Crucially, we must provide a description for each tool, such as useful for finding information on the internet. The LangChain create ReAct agent function binds the LLM, the tools, and the specific ReAct prompt template together. Finally, we use the agent executor. We simply invoke it with our input string, and the executor automatically handles parsing the model's action output, calling the respective Python function, and feeding the observation back into the model until a final answer is reached. It is a fully automated cognitive loop. Let's break down this powerful LangChain implementation. We instantiate our Bedrock LLM client using Claude v2. We initialize the Wikipedia API wrapper and bind it to a tool object, explicitly defining its name and description. We pull a standard ReAct prompt template from the LangChain hub. We then use create ReAct agent to fuse our LLM, our tool array, and our prompt. The agent executor takes over. When we call invoke with our question about DNA, the executor manages the entire ReAct loop under the hood, calling Wikipedia, observing the result, and returning the final synthesized answer. Enabling verbose equals true lets you watch the thought, action, observation trace live in your console. This shows the agent executor logic. The invocation constructs the prompt and calls Bedrock. If an action is required, the executor runs the tool and returns the observation back into the loop under the watch loop. Once no further actions are needed, it returns the final output.
While LangChain is fantastic, AWS offers a fully managed serverless solution that deeply integrates this paradigm: Amazon Bedrock Agents. Bedrock agents empower you to build autonomous agents that can perform actions based on organizational data without having to write the underlying orchestration code or manual ReAct prompt engineering. How does AWS handle the magic? Bedrock agents orchestrate interactions between foundation models, software applications, and user conversations. You configure the agent by providing instructions defining its persona. Then you define action groups. An action group consists of an open API schema that defines the API operations the agent can invoke and a Lambda function that executes the business logic. Bedrock automatically parses your open API schema to understand what tools are available and generates the underlying ReAct prompts dynamically. When a user makes a request, the agent breaks down the task, determines which API in your schema to call, invokes your Lambda function, receives the observation, and crafts the final response. It is a fully managed enterprise orchestration engine. Observe the fully managed Bedrock agent workflow. The user prompt hits the agent, which analyzes the attached open API schema to determine the correct API call. It invokes the Lambda function, executing backend logic, and uses the return data to generate the final response.
When working with autonomous systems, visibility into how the model reached its conclusion is paramount for security and debugging. How do we monitor a Bedrock agent's internal ReAct loop? We utilize traces. During runtime, users have the option to invoke a trace, unlocking a window into the agent's thought process. The agent's performance unfolds in 3 phases: pre-processing to categorize input, orchestration where the ReAct loop occurs, and post-processing to format the final response. The trace meticulously tracks the agent's rationale, actions, queries, and observations at each step of the sequence. It includes the full prompts sent to the FM, API responses from your Lambda functions, and knowledge base queries. By examining this trace payload returned in the API response, you can see exactly why the agent chose a specific tool or what data observation caused it to hallucinate.
Enabling enable trace equals true in your invoke agent API call is an absolute best practice for ensuring transparency and continuous refinement of your generative AI applications. This illustrates the debugging power of traces. By setting enable trace to true, you gain visibility into the pre-processing, orchestration, and post-processing phases. These traces combine to form a comprehensive audit log of the agent's entire cognitive pathway.
As we deploy ReAct techniques and autonomous agents into production, we must adhere strictly to enterprise best practices. First, the performance of your agent is entirely dependent on the quality of your tool descriptions. If your OpenAPI schema descriptions are vague, the model will struggle to determine which tool to use, leading to failed execution loops. You must describe the inputs, outputs, and purpose of every tool with extreme precision. Second, what happens when an API fails? Your Lambda functions or LangChain tools must handle errors gracefully and return descriptive error messages back as observations. If an API times out, the tool should return API timeout. Please try a different search parameter, so the LLM can reason about the failure and retry intelligently. Finally, security. Because agents can execute backend logic, you must strictly enforce the principle of least privilege using IAM roles, ensuring the agent's Lambda function can only access explicitly authorized databases and services. Mastering ReAct transforms AI from a chat interface into a powerful operational tool. We invite learners to like, subscribe, and visit quicktechie.com for premium and for recently updated material as per latest syllabus and certification prep. Q&A banks, ebooks, audiobooks, full training, interview guides. On YouTube, it may not be a latest contents. This diagram maps best practices to outcomes. Precise descriptions guarantee accurate action selection. Graceful error observations empower intelligent retries. Strict IAM privileges ensure secure backend execution. Together, these forge a robust enterprise-grade agent.